2009 Grade 9 Friar Math Contest. Emily sets up a lemonade stand. She has set up costs of $12, and each cup of lemonade costs her 15 cents to make. She sells each cup of lemonade for 75 cents. What is the total cost, including the setup, for her to make 100 cups of of lemonade? All right, so we've got $12 is sort of this basic setup cost, and then for each additional cup, it's 15 cents. So in this case, we want 100 cups. So that's basically the formula right there. And then you just, I guess, solve this. So this is 12 plus 15, which is 27. So that takes care of part A. Part B, what is her profit? Money earned minus total cost if she sells 100 cups of lemonade. Okay, well, she's selling them for 75 cents, right? So when she sells 100 cups, it'll be 100 times 75, which is her profit, which is $75, correct? And then her cost, we just calculated up there. That was $27. So her profit is basically how much money she makes, which is $75, minus her costs, which is 27, and that is 48 bucks. Okay, part C. What is the number of cups that she must sell in order to break even? So that means having a profit of 0. So basically they're combining part A and part B. So they're saying that we want to break even. So our cost is basically our revenue is 75 cents times the number of cups she sells, which I will represent by C. And then I guess our cost, so this is how much revenue, and our cost is very similar to up here. It's $12 plus 15 cents per cup of lemonade. So 12 plus 0.15 C. All right, so then you just solve for this. So this is 0.75 C minus 12 minus 0.15 C. Move this up a little bit. And that looks like it's going to be 12 equal to 0.60 C. And therefore C is going to be 20. So 20 cups of lemonade is the answer. And then finally, why is it not possible for her to make a profit of exactly $17? Okay, well, I guess instead of the 0, now we have to put 17. And the rest of the formula is the same. 0.75 C minus 12 plus 0.15 C. Okay, so let's see what happens. Okay, so we got 17 is equal to 0.75 C minus 12 minus 0.15 C. And then this looks like 29 is equal to 0.6 C. And therefore C would be 48.33. So C must be an integer, right? Because C represents the number of cups. So we can't have 48.33 cups. I mean, I guess you could, but in this case, we want this to... They don't indicate that you're selling a fraction of a cup. So because of that, C must be an integer, and it can only be 17 if C is equal to 48.33. And therefore, since C must be an integer, this 17 would never be possible. So you can just write that out in a sentence format. If A greater than 0 and B greater than 0, a new operation, a symbol, is defined as follows. A symbol B is equal to A plus B over 1 plus A plus B. For example, 3 symbol 6 is equal to 3 plus 6 over 1 plus 3 times 6, which is 9 over 19. Calculate 2 symbol 5. So we will just use the exact same definition up there. So that would be 2 plus 5 over 1 plus 2 times 5. So that looks like 7 over 11 to me. Calculate this guy. So this guy is a little bit different. It's 1 symbol 2 and then symbol 3. So first let's calculate just that. So according to our definition up here, that's going to be 1 plus 2 over 1 plus 1 times 2. And then we'll do the symbol 3 later. Let's just calculate that. So that looks like 3 over 3. Yeah, okay. So that means that's just going to be 1 symbol 3. And then now we repeat the same thing. So according to the definition, that is 1 plus 3 over 1 plus 1 times 3. So that is 4 over 4, which is 1. Okay. So I guess 1 is the answer. All right, so in part C now, if 2 symbol x is equal to 5 over 7, what is the value of x? Okay. So we have 2 symbol x is 5 over 7. All right. Okay, shouldn't be so hard here. Let's use the definition. So it's basically 2 plus x over 1 plus 2 times x, and that's 5 over 7. So I guess we just have to solve that. Okay, let's cross multiply here. So we have 14 plus 7x, and that looks like 5 plus 10x. And then that looks like 3x, that looks like 9, and therefore x is equal to 3. And I think that's it. Now finally we get to D. For some values of x and y, the value of x symbol y is equal to x plus y over 17. Determine all possible ordered pairs. Okay, so ordered pairs. All right. So we're going to need some space here. So they're saying that x symbol y is equal to x plus y over 17. All right. So this, according to our original definition, is x plus y over 1 plus x times y. And then this is x plus y over 17. All right, so I guess we just have to solve this. So cross multiplying at 17x plus 17y is equal to, oh, I see. I don't even need to go through all that. This is the same as that. So that means this must be the same as that. Okay, let's make life a little bit easier for myself. Is equal to 17. So therefore xy is equal to 16. Okay, so I guess I just have to find two values that multiply together to get 16, and keeping in mind that x and y are positive integers, because that's the criteria, right? I think. Let's go back. Yeah, they're positive integers. Okay. All right, so well, let's see. 1 and 16, that'll work. 2 and 8. 3 does not work. 4 and 4 works. 8 and 2, and 16 and 1. So these are the ordered pairs. And you can write them out like x, y can be 1, 16, 2, 8, dot, 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 and so on, right? Just list them all. In the diagram, K, O, and M are the centers of the 3 semicircles. OC is 32, CV is 36. What is the length of AC? All right, so AC, to me, is the full diameter of that semicircle. Now, in that diagram, it looks to me that AC is equal to AO plus OC, right? Now, AO is half of the semicircle diameter, the big one. So they told me, let's see, do they give me any clues in here? Let's see here. OC, yeah, they give me up here. OC is 32, right? So O to C is 32. And then C to B is 36. So this is 32, and then here is 36. So that means that from O to B is 32 plus 36, which is what, 68? So since O is the center, that means O to A is the same. It would be also 68. Yeah, because AO is equal to OB, because they both represent the radii of that large semicircle. So AO, this guy, is 68. Okay, so we got one. And then OC, well, OC, they gave me in the question. That's just 32. So 68 plus 32, I believe, is 100. Yeah. Okay. that's all that was. What is the area of the semicircle with center K? All right. So center K. Okay. So I guess they're talking about this one here. This one. So the area, of course, is pi r squared, but we need to figure out what is pi. Well, not pi. R is what I should be saying. But it's a semicircle, so be careful. So it's actually pi r squared over 2. And then we have to figure out r. Okay, r shouldn't be that hard to figure out because from A all the way to C is the diameter. So that's going to be 68 plus 32, which is, well, 100. We just figured that out. So that means the radius, which would be A to K, which would be half of 100, which is 50. So that's the radius. So there, this is going to be pi 50 squared all over 2. And therefore, 50 squared is what? 2,500? So if you take that, half of that, it'll be 1250. So 1250 pi. All right, great. Letter C, what is the area of the shaded region? Okay, so the area of the shaded region looks to me like basically it is the area of the big semicircle, so pi r squared over 2, minus the areas of the 2 smaller semicircles. So that is what I would write out. So basically the area of the big one minus this one and minus that one. So all we really need to do is figure out the radii. Okay, the big one, we just did that one. So that one, well, actually, hold on. Let me backtrack a little bit. The big one, the full distance from A all the way to B is 68 plus 68, right? This 68 plus this 32 plus this 36. So that is whatever it is, 136. But we just want the radius. So the radius is just 68. So that's what goes in here. Okay. Now this guy, the radius of that is, I think we just figured that out right here, 50. Oh, well, 50. So pi 50 squared over 2. And then this guy, this smallest one, well, CB from here to here is 36, so half of that is the radius, so that means 18 is the radius. And I think that's it. So this is going to be, well, we can factor out the pi over 2, and then it becomes 68 squared, which is 4624, minus 50 squared, which is 2500, minus 18 squared, which is 324. And when you crunch out these numbers, you get 1800 pi times pi over 2, and that's 900 pi. All right, that's good. Okay, we got one more here. All right, let's look at the last one. Line L is drawn to touch the smaller circles, semicircles at points S and E, so that KS and ME are both perpendicular to L. Determine the area of quadrilateral KSEM. Okay, so I'm gonna have to draw a little bit of a diagram. Nothing too complicated. Just let me just draw those lines in that they talk about, and I think that will set this up a little bit better. So we got M to E, right? Yeah, something like that. And then what's the quadrilateral? KSEM. KSEM. Okay, so basically the shape that I just created, and let me just draw that in. So KSEM is this shape right here. KSEM. So like that. Okay. All right. So I got to figure out the area of that. Now, how am I going to do that? Okay. Well, well, one thing I can do, make my life a little bit easier, is break this up into 2 parts. So I'll make it sort of like that, but let me draw a slightly better line. So there you go, like that. And that line that I just drew is basically parallel to SE. So now this is like a rectangle. And if you notice, this M to B is a radius, right? And we figured out up there that that was 18. Now M to E is also a radius, so that's 18. And since this is a rectangle, since I drew these lines perpendicular, from this point to this point is also 18. And now, let's see, I obviously have to figure out the dimensions here of the other guys. So from K to S is the radius, right? From K to S is the radius of that semicircle. Now, K to C is also the radius. And we had figured out up here that the radius of that semicircle was 68. If I am not mistaken. No, not 68, sorry. We had figured it out that it was 50. Yeah, right there. So that means K to C is 50, right here. So that means K to S is 50, right? Because KS represents the radii. Now, since this part is 18, that means from here to here is 50 minus 18, which is 32. From this K to this point right there. Okay, so we're getting somewhere here, I think. All right, so what's the next step here? I believe the next step is going to be to figure out the length from here to here, this guy right here. Right there, that distance. So that distance, I think we can probably get through Pythagoras, because this is a right angle, the way I drew those. So 32 plus, I'll just call that distance x. 32 squared plus x squared is equal to, from K to M. K to M is 50 plus 18, which is 68. Okay. So therefore, x squared is going to be 68 squared, which is 4624, minus 32 squared, which is 1024, which is 3600, and therefore x is the square root of that, which is 60. So there we go. That's 60 right there. Okay, so since that's 60, then that means S to E is also 60. All right, so now we have everything we need. KSEM, the area, will first be that rectangle, which is pretty straightforward. That's just 60 times 18, plus that triangle, which will be 1/2 base times height. We can use 60 as the base, and we can use 32 as the height. And when you crunch out these numbers, you get 960 plus 1080, and that is 2040. And there you go. The addition shown below represents 2 plus 22 plus 222 plus 2222, and so on. It has 101 rows, and the last term consists of 101 twos. Determine the value of the ones digit A. Well, I guess we just have to add up all these guys right here. And they told me there's 101 rows, so I'll just write this is the first row, this is the second row, third row, fourth row, and the last one is the 101st row. So when you add up that column, and basically it's 2 plus 2 plus 2 101 times. So it's 2 plus 2 plus 2 plus dot 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 plus 2, and there's 101 of these 2's. So it's 101 times 2, which is 202. So that means this A would be 2. And then it would basically be the A is 2, and then you'd have to carry the 20 up here, I guess, like that. So that's basically all that is. Okay, determine the value of the tens digit B and the value of the hundredths digit C. Okay. So when we do these guys, this is going to be pretty much the same thing, but we got to make sure we include that carry. So now this row, or sorry, this column, I guess, would be the same thing. A whole bunch of 2's, and then that 20. But remember, there's no 2 here. So it's not 101 like it was. It's only 100 2's this time. So it's 100 2's. And then don't forget that 20. So it's 220. So because it's 220, that means this would be a 0. And then you carry that 22 up here. So B is a 0. And same thing, I guess, here. This time, remember, we don't have a 2 here and we don't have a 2 here, but we have these 2's, and that means there's 99 2's this time. So that means we have 99 times 2 plus that 22 carry. So that's 198 plus 22, which is 220. So again, this becomes a 0. And then, sorry, let me write it on the diagram here. So it would be the 0, and then we carry the 22 right here. Right, just like that. And they just keep going like this, basically. And it just kind of continues in that fashion. If you just keep doing exactly what I'm doing, you'll get that this is the next one. We did the A, the B, the C. The next one, if you want to call it D, whatever you want to call it, it would actually be an 8, and you would have to carry a 21 this time, like that. And then you do for the next one, and it would be a 5, and you'd carry a 21 again, and then you just keep repeating that. So we got C equal to 0. Okay, determine the middle digit of the sum. Ooh, okay, middle digit of the sum. All right, middle digit. Well, first of all, we have to figure out how many digits are there in the total sum. Interesting. Well, the very last row has 101. This one has 101 digits, right? So the sum is always going to have 101 digits, because if you look at it, it won't increase the number of digits, because this digit will always remain a 2. So that means the middle digit, I believe, would be the middle digit of 101, which is 51. So 51 is the middle digit. Is the middle digit of that entire sum. So what I'm going to do is sort of just do what I've done so far for A, B, C, right? And then the 4th, the 5th, the 6th, the 7th, and then I'll just sort of keep extrapolating, and then eventually, hopefully, we'll get something down to the 51. So the first one, if you remember, I just did 200 times 101, which is 202, and therefore the A was equal to 2. And that's just up here. I mean, I just did that. So the second one, B, I did 2 times 100, and then remember we had to add the carry. So that was 220, and therefore B was equal to 0. And then the C was 2 times 99, and then remember we had to add the carry, which in that case was 22, right? Yeah. So that became, interestingly, 220 again. So that means the C is 0, because the C was this guy, this was B, that was A. Now the fourth one, it would be the same kind of thing. It would be 2 times 98, and then you'd have to add a carry. And I think we did that. The carry was 22 again? Yeah, the 22. Okay, so 22. And I believe that was, let's see here, 196 plus 22, so that's going to be 218. And that's how we got that digit to be 8. And then you just keep going, 2 times 97. And I think the carry this time was 21. Yeah, see, it's right there. So that means this is going to be 2 times 97 plus 21, which is 215, and therefore that was a 5. And then that's it. You just keep going. I hope you guys get the hang of this. So 2 times 96, and then the next carry, I believe, is 21. And therefore that is going to be 213. So that's a 3. That particular, the 6th digit. The 7th one is 2 times 95. The next carry is also 21. And you're getting the carries from these, see? You see what I mean? You say, well, how did you know 21? Well, 21 right there. So that 2 times 95 plus 21 is 211. So the 7th digit is a 1, because that's this guy. And then again, 2 times 94, because these ones just keep going down, right? 101, 100, 99, 98, and down. And then to get the carry, just look at those two numbers. So that's a 21. So 2 times 94 plus 21 is 209. So this 8th digit is a 9. And then let's just do one more. This is 2 times 93. And then carry this time is a 20. And that is 206. And then you just keep doing this, basically. And when you get all the way down to the bottom, it's very time consuming. 2 times 51. And then this time the carry is 11. And that gives you 113. And therefore, that 51st digit would be a 3. Now, you might think, was there any shorter way? And there is another way, but the other way in the official solutions is just as complicated, or actually the complicated is not the best word to use, is just as time consuming as this. So I'd prefer to just do it this way. Yeah, it's time consuming, but it's the final question, and they're kind of making you sweat a little bit because they want you to, get to that finish line. And it's really not that difficult in terms of the math. It's just going to take you some time.